7. It's linear and quadratic systems. What we're doing today, we've done, I think it was back in chapter 1, we spent a bunch of time working with elimination, substitution, graphing to solve systems of equations, but they were always 2 lines. So they are linear systems. Here we have a line and a quadratic. Okay? So as we look at, we've got 4 things to go through. We look at the first thing. It's solving a linear quadratic system using graphing. So we're going to graph each of these. Let's start with y equals x squared plus 6x plus 9. Okay. Do we remember anything about options of how we could graph this? Or let's start with, what shape is this? Yeah, it's an x squared, so it's a parabola, isn't it? Okay. Now, this is a parabola that's in standard form. So it's that ax squared plus bx plus c form?
Yes.
How do we graph those? No.
Wait.
Save that for our lines. We'll do that next. Do you remember a formula to find our axis of symmetry?
Is it on the green paper?
No, but it's on the blue paper. X equals negative b over 2a.
Yes.
Okay, we use that. We use that back on our chapter 2 quiz.
Yes.
Okay, axis of symmetry. So let's find our axis of symmetry. Negative b. So what are we going to say here? I didn't write down my ABCs. You guys know them. Negative of b. What's b? 6 over 2 times a. What's a? 1. So negative 6 over 2 becomes negative 3. So we have an axis of symmetry of x equals negative 3. Once you know your axis of symmetry, what can you then find? The vertex. What do I know about my vertex right now? I know my vertex is negative 3 comma something. How do I find something?
You gotta plug it in.
Take that negative 3, plug it into my equation. So that means I'm doing what? Negative 3 squared plus 6 times negative 3 plus 9. Excuse me. Negative 3 squared is 9. 6 times negative 3, negative 18 plus 9. What is 9 minus 18 plus 9? 0. So we know we have a vertex of negative 3, 0. Okay. And there's one other piece of information we could get to help graph this. And I guess there's a couple of different ways we could look at. One option is, do you remember where we get our y-intercept from? Y-intercept is the what value?
C.
Yeah, and what is my C value here? 9. So one option you could use to help finish graphing this is that the y-intercept is 9. The other thing is, what kind of x squared was this? This is a 1x squared, yes? What kind of shape do parabolas have if it's 1x squared? How far what do they go over and up from the vertex?
So like 1 and 1 and then like 2.
Yeah. So you could also use the idea of 0, 0, 1, 1, 2, 4. Okay, I'm just giving you options here. Okay, let's graph this. Now, axis of symmetry is x equals -3. In all honesty, I'm not going to put that on here because it becomes too confusing. But you guys know the axis of symmetry does what? If I was putting it on here, it would go that way, right? Now, as I said, I'm taking that off because I don't want the extra lines. What's my vertex? -3, 0. Now, officially, we could look at the c-intercept is 9, or the c-intercept. Y-intercept is 9, and where is 9?
All the way up there.
Up 9. Now, think about this. My axis of symmetry is here at -3. This point is up at 9, but it's to the right 3. Where's an equivalent point?
So left 3.
To the left 3. Now, I would encourage a few more points here because of what we're doing today. Because while this gives us a good parabola, it's not going to help us find what we're looking for, which is that point of intersection. So think about this. From the vertex, we go where? Over 1, up 1, and?
Over 2, up 4.
Over 2, up 4. The advantage of me putting those points in is I know a little bit better exactly where my parabola is going. Okay? So I'm going to put my parabola up there. Okay. So there's my parabola. What else do we have to graph?
The y equals x plus 3.
Yeah, we have this other line. Don't forget about it. Y equals x plus 3. What do you know about y equals x plus 3? What form is it in? Emma, I told you earlier, hold on to that. What form is this in? Yeah. This is y equals mx plus b, isn't it? If this is y equals mx plus b, what do we know? Our b value is 3, which is, that's going to be our what? Y-intercept? What's our m?
1.
The invisible 1. And what is 1 as a fraction? 1 over 1. This is our slope.
Q.
What's our phrase for slope?
Rise.
Rise over run, yes? Okay, so let's graph this line. So I'm going to start with a y-intercept at 3, which means I'm going up 3. From that, we're going to rise 1, run 1. So up 1, right 1. Up 1, right 1. I can keep making an infinite amount of points, yes? But is going up 1, right 1 really helping me? Not really. I should probably reverse this and do what?
Down 1, left.
Down 1, left 1. Down 1, left 1. Down 1, left 1. Down 1, left 1. Okay, guys. What happened along the way?
Yeah, like 2 same points.
Yeah, I intersected at 2 points. Now, I know these points are kind of hard to see, aren't they? Okay, but they're there. Okay, so this is a straight line. Okay, so it was solve each of the following systems by graphing. What am I looking for in terms of answers?
Is it gonna be like two sets of points?
Yeah, 2 sets of points, 2 ordered pairs. Okay. What are those 2 points?
The bottom one's like -3, 0.
Yes?
The other one's -2, 1.
Okay. In this case, we have 2 points. Now, a lot of times when you have a parabola and a line crossing, there's 2 points. There's not always going to be 2 points. There could be no points. My line could go below or above to the parabola to where they don't touch. Or there's also the possibility of 1 point, where my line just catches 1 point of that parabola. Okay? Questions here? I didn't really teach anything new, did I? I didn't teach anything new. Now, I know it's some stuff we need to review on. It's some tough stuff. I'm not going to argue that. But I didn't teach anything new here. Okay? Okay. Ready to try the next one? Y equals -x squared plus 2x plus 5, and y equals 2x plus 5. Okay, I'm going to start with this parabola. Y equals -x squared plus 2x plus 5. We need to work to find that vertex, which means we need to start by finding our axis of symmetry. X equals, what's that formula? -b over 2a. Negative of b. Well, what's b? 2. So that's going to be -2 over 2 times, what's a? -1 in front of the x squared. So -2 over, what's 2 times -1? -2. -2 over -2 is 1. I have an axis of symmetry, x equals 1. What do you know?
You already know.
Yep. In my vertex, I know it's 1 comma something. Now be careful on this one. We're going to take that 1 and we're going to plug it in. So y equals, now notice it's the negative of 1 squared plus 2 times 1 plus 5. What about the negative of 1 squared? -1, right? Because when you have that negative out front, it automatically makes the answer negative. And 1 squared is 1, obviously. So this is going to be -1 plus 2 times 1 is 2 plus 5. -1 plus 2 plus 5 is 6. So now I have a vertex of 1, 6. Okay. Options for how we're going to graph the rest of this. One thing I know, my y-intercept is that c value of 5. And it just kind of depends on the situation. What about this parabola? It's y equals -1x squared.
Like 0, 0, -1, -1, -2.
Yeah. So I still write it as 0, 0, 1, 1, 2, 4, meaning we can, from the vertex, go over 1 and then up or down 1. In this case, it's going to be down 1 because what do we know about this parabola? It's a -x squared, so it's going to be upside down, isn't it? So it's going to be over 1 down 1 over 2 down 4. But we can still use those values because it's a 1x squared. Okay, let's graph it. So x equals 1. There's an axis of symmetry right in there, yes? Again, I'm not putting it on there. I don't want the extra lines to confuse issues. So vertex at where?
1, 6.
1, 6. So you went right 1, up 6. And then you could look at a y-intercept. A y-intercept of 5 is what? Right beside it there. Over 1, it's, it's right there. Now, if that point is to the left of my vertex, that means there's an equivalent point to the right of the vertex. Well, this just ended up taking the spot of what? My over 1, down 1. Now, it's helpful to have a few more points. So we can go over 2, down 4. If you really wanted to, or if you needed to, you could go more points. 3, 9, 4, 16, 5, 25. Obviously not that much, but the 3, 9 is the only other one that might be helpful, but we don't need it on here, so. Okay, I'm going to draw my parabola. Okay, and what else do we need to do? Don't forget about y equals 2x plus 5. What do you know about y equals 2x plus 5?
Y-intercept of 5. The m equals 2 over 1.
Yeah. Y-intercept of 5. And my slope, or my m value is 2, and 2 as a fraction is 2 over 1. So y-intercept of 5. Oh, hey, guess what just happened? We already have a point there, don't we? That's nice. So I'm going to have a y-intercept of 5, and then my slope is going to what?
Go up 2 over 1.
Up 2 over 1. And then we can also reverse that and go down 2, left 1. Okay. Thoughts of what's happening there? It's kind of hard to tell, isn't it? But what do we have to know? We have to know where our graphs are crossing. Where are they crossing?
At the 5, 0.
Okay, we know they're crossing here, yes. Okay, which is the ordered pair
0, 5.
0, 5. Up above there were 2 answers. Do I have 2 answers here? No, you don't. This is one where my line is tangent to my parabola. It's just going to touch it in one spot, and it's not going to actually cross through it. So we just end up with one solution, as opposed to the last one where there were 2 solutions, right? Okay. That's a little bit of a review of graphing. If this homework is the homework I'm thinking of, I didn't put much. I don't think I put much of this type of graphing in there. I forgot to check, but I really don't think I did. Okay. Okay, questions there? Still gotta know how to graph, right? Y equals mx plus b. I expect you to be pros at that. Okay. That's, I expect us to know that. We just have to not make mistakes. Practice graphing the parabolas. That's something we've done a lot of this chapter. Okay, that's something as Algebra 2 students we've got to work to grow that skill. Okay? Okay. Ready to take a break from graphing now?
Yeah.
Okay. We are solving now. Officially, we could argue that we're going to solve substitution or elimination here. Okay? Technically, both will work. I have that I'm set up to teach substitution, and I mean, it's really not bad either way. They're very similar in how they work out here. Okay? Because what you're going to be given today is you're always going to be given two equations that are y equals. And if we're given two equations that are y equals, it makes the substitution not bad. So if you recall substitution, how it works. You need one equation that is either solved for x equals or y equals. Well, what do we have here?
Y.
We have two equations solved for y equals, right? And then if you recall, the idea was once you have an equation solved for x equals or y equals, you take that equation and you plug it into the other equation for whatever it is. Okay? We have two y equals. If both equations equal y, what does that mean about those two equations? One of them equals y, the other equals y. That means they both equal the same thing, right? If they both equal y, they equal the same thing, which means we can take these two equations and put them equal to each other.
Oh.
Are you seeing where I'm going with that?
Yeah.
Okay, so the idea here that since this is y equals negative 3x squared plus x plus 4, and this is y equals 4x minus 2, doesn't matter which way you do this, we're going to take one of the equations and put it in place of y. Okay, if I take one of my equations and put it in place of y, well, that means I'm going to have, instead of y equals 4x minus 2, I'm going to have negative 3x squared plus x plus 4 equals, what's the other piece of this? 4x minus 2. Okay? So both equations are y equals. When they're both y equals, you just set them equal to each other and do your math. Okay. Thoughts on what to do with this?
Probably like subtract 4 and add 2 to the other side. Make the 4x equal 2.
Do we want to make the equation equal to 0? Yeah. Here's the deal, guys. I have an x squared term. I have x's. I have numbers. We're going for that ax squared plus bx plus c equals 0. Okay? So, let's see. Eliazine, you suggested subtracting 4x and adding 2. I'm all for it. If I subtract 4x on the right, subtract 4x on the left. If I add 2 on the right, add 2 on the left. Okay? Write out what you have. Still negative 3x squared. There was x, or 1x, and what are we doing with that 1x? We're going to subtract 4x. What's 1x minus 4x? Minus 3x. It was 4. We're going to add 2. 4 plus 2 is 6. And it equals 0. Okay. What do you see?
This is going to be like the negative b plus or minus.
What we did yesterday?
Yeah.
Quadratic formula? Here's what I'll say. You could use quadratic formula, but we don't have to. There's actually what I would call an easier way to do it. What way do we always like to use if we can? Or at least I'm guessing you guys do. What's easier than quadratic formula for you?
Quadratic formula, I don't know.
That was easy for you. Okay, well, yeah. Generally, I like to lead in the direction of factoring if I can. Okay. Now, what do you notice about all three terms here?
You can take it like the 3.
Okay, they all have a 3 in common, yes? GCF?
Yeah.
Yes, of 3. Now, because it's an equation and it equals 0, I can actually just divide out that 3. I can do that because it's an equation, okay? I'm not just factoring. So if I'm trying to solve this, I can divide out the 3. Now, what's going to make life even better? If I divide out a,
3x.
not 3x,
Negative.
a negative 3. So I'm going to divide both sides by negative 3. Okay? So, with that in mind, negative 3x squared divided by negative 3 is x squared. Minus 3x divided by minus 3 is plus 1x. 6 divided by negative 3 is minus 2. 0 divided by anything is 0. Again, you could still go quadratic formula route, but to me, I see an easier route. X squared plus x minus 2. What are we guessing that's going to look like when we factor it? We're hoping it goes into 2 parentheses, yes? We don't know if it will, but we're hoping it will. X squared is going to break into 2 x's, x times x. What about my numbers?
It's gonna be like -1 and -1, or like it's gonna be ones.
Well, how do we multiply? What do we have to multiply to get?
Oh, 2.
Yeah. We're going to get a product, or multiply to be negative 2, and it's going to add to be 1. Well, how do you multiply to be 2? It's some combination of 2 and 1. If it multiplies to be a negative, then you need a negative in there. If it adds to be a positive 1, bigger number is positive, because then 2 minus 1 will be 1, and 2 times negative 1 is negative 2. Okay? So the numbers we came up with there are 2 and negative 1. What do we do from here? You guys know.
Oh, set them both equal to 0.
Yep. Set each factor equal to 0. X plus 2 equals 0. X minus 1 equals 0. We're going to solve them, yes. I'm going to solve them. I get x equals negative 2 and x equals 1. Am I done?
Probably not.
She says probably not.
Plug it in, maybe.
Plug it in maybe. Okay guys, think about up on my graphs, what kind of answers did we have? They were ordered pairs, right? They were XY combos. What did we just find?
X.
X. So what I know at this point is that I'm going to have 2 answers. One answer is going to be negative 2 comma something. The other answer is going to be 1 comma something. Does that make sense? And then, so how do we find the somethings? As you guys said, that we need to plug them in. Now, make life easy on yourselves. What would you like to plug them into?
The bottom of the 4x minus 2.
Yeah. You get to pick one of the 2 original equations, yes? Let's be smart about this. The line's going to be easier, isn't it? So we're going to plug into y equals 4x minus 2. So y equals 4 times, the first time I'm going to do negative 2 minus 2. 4 times negative 2 is negative 8. Negative 8 minus 2 is negative 10. So now I have an answer of negative 2, negative 10. And do the other number too. Y equals 4x minus 2. So 4 times 1 minus 2. 4 times 1 is 4. 4 minus 2 is 2. And so I have an answer of 1 comma 2. Okay? 2 ordered pairs.
So would you get the same answer if you did quadratic formula?
If you did quadratic formula, you would have gotten the negative 2 and the 1. And then you'd still have to take the negative 2 and 1, though, and plug them into an equation. So, yeah, you would have. Okay. What do we have, about 5 minutes? Okay. I don't know if we can get through with this other one or not, but let's at least start it. Practice the steps. We may have to restart here tomorrow. What is step 1?
Yeah. Could you take out the GCF?
Hold this thought yet. We're going to be able to do both of these things. Sum equal to 0 and take out GCF. But first of all, we've got to create one equation. Set them equal to each other, right? They're both equal to y. So basically, you're taking one of the pieces or the other and putting it in for y. So they're going to equal each other. So 2x squared minus 6x minus 8 equals 2x minus 16. I would suggest setting them equal to 0 before we're trying to divide a GCF out. Okay, just because you might get, probably not, but you could always get a bigger GCF once you put them together. So, okay, we have this. In order to make it equal to 0, what are we going to do?
Subtract 2x, add 16.
Subtract 2x, add 16. So when we rewrite this, 2x squared minus 8x, because minus 6 minus 2 is minus 8. Minus 8 plus 16 is plus 8. Okay. Now, do you see something to make life a little easier? Yeah, they all divide by 2. So let's divide everybody by 2. Again, I can do this because it's an equation, and I can divide both sides. So now I have x squared minus 4x plus 4 equals 0. Oh, we can do this. Piece of cake, right? You're with me. What do you know? X squared is x and x. What multiplies to be 4? So what gives me a product of 4 and a sum of negative 4? No?
Oh.
2 and 2?
Oh, yeah, both.
We're forgetting the obvious. 2 times 2 is 4, and negative 2 plus negative 2 is negative 4. Now, when we go to set these equal to 0, do you really have to set both equal to 0? They're the same thing, isn't it? It's just x minus 2 equals 0. What are we going to get in both cases? X equals 2. Am I done?
No.
No. What do we know? You're going to have an answer that is 2 comma something. Where do I put that 2?
The bottom equation.
Pick an equation. Eliazian keeps telling me the bottom one. I don't blame him, though. So, y equals 2 times 2 minus 16. 4 minus 16, which is negative 12. So we have a final answer of 2, negative 12. Kind of like their graphs. It just worked out that there was only one answer. Okay. Tomorrow, we'll graph a little bit with inequalities. So yes, I think it was Emma earlier that mentioned the shading. Shading is back. And then we'll also practice a little bit with Desmos again. Okay. Make sure you guys get up through 2-6 done by the end of the day tomorrow, please.